In this video we'll look at the sine source. I've got the voltage source from the previous video that we used for the pulse source still on the schematic. We can see that we've got a simulation command down here at the bottom of a transient command with a 20 millisecond time period. We'll right click on the voltage source, select advanced, and then select a sine source. Again, you get a list of parameters available for the sine source. The DC offset value is the first parameter. We'll leave that at 0, and then we'll put an amplitude of 2 volts and a frequency of 1 kilohertz and test that. Do the simulation, and again on our schematic we'll hover over the node point at the positive side of the voltage source, and we get a voltage probe and click there, and we see the sine wave source there. In this case we're showing too many cycles of our sine wave, so we can change our simulation command. If we hover over the simulation command and right click on it, we can change it to a 10 millisecond transient. OK that, and then resimulate, and we get a better view of the sine wave. We can look at a few more parameters. Right clicking on this, we can change our DC offset to, let's say, 3 volts for now. OK that, and do a simulation, and you'll notice the sine wave is now has a average value of 3 volts across the axis right there. Right click again, I'll change that back to 0, and we'll look at the time delay. This is just a delay before the sine wave starts. I'm going to set this at 2 milliseconds. OK that, and simulate. And there you see a 2 millisecond delay before the sine wave actually begins to oscillate. Change this again. The theta designation is an exponential decay, or actually you can put a negative value in there and get an exponential increase of the sine wave amplitude. We'll experiment with that. If I put a 1K value there, OK that, and simulate, you can see I get an exponential decay in the amplitude of the sine wave. If you look at the units for that value, it's 1 over s, and so what you're putting in here is actually the reciprocal of the time constant of the exponential decay value. I'm going to take that back to 0 because that's probably not used that much. And now we go to the phi. This is just a phase shift on the sine wave. I can put a 90-degree phase shift in there. OK that, and resimulate. And now I have a cosine wave that's just a 90-degree phase shifted sine wave. I can change that to a 180-degree phase shift, and I get the inverse of the sine wave. And then the last parameter here is the number of cycles. I can designate if I want to have the sine wave go for 3 cycles, and OK that, and simulate. And I get 3 full cycles of the sine wave.